Hey, Gio, welcome back. We're going to start our process here of geometric proofs, right? So we've done algebraic proofs, used addition property, subtraction, all those properties of equality. We're going to review reflexive, symmetric, and transitive. And then just know that in geometry and geometric proofs, we're going to go back on previous knowledge on things that we've done before. So we might not go over a specific example always, but if it says complementary, you have to understand and remember complementary adds the 90. So you'd have to do the two angles added together equal 90. We're going to use definitions, right? So let's just review reflexive. Reflexive, think of a reflection. It's the same thing, right? Reflection, reflexive. Symmetric, it doesn't matter the order in which you equal things, right? 6 is equal to 2 times 3, or 2 times 3 is equal to 6, doesn't matter. And the transitive property, if two things are equal to two separate things, then I could take those two separate things and set them equal, right? So now we just have the idea of properties of equality, and then now just that property of congruence. If two things are congruent, versus equal, right? Same concept. There is a little difference between them, but it's all right. The other thing with geometric proofs, if they don't give you a diagram, if they don't give you a picture, please draw it out. Also, I like to solve things on the side by myself before I put it into the final proof. So that's something you can do as well. I'm going to go through and solve as we're going through, but do the work. I always say it's the rough draft on the side, and then do the final copy is going to be your proof. Okay, so let's just relook at the segment addition postulate. This was back in try 1. Part plus part equals the whole. The two smaller pieces add together to equal the whole thing, right? So here is a diagram that's not drawn for us, so let's fill it in. L is between, doesn't have to be in the middle. X plus 3. LK is 2x minus 19, and then the whole thing is 23, right? So way back in unit 1, beginning of the year, this is what it looked like. So to set this up, we would do the small part, NL, plus the other small part, LK. That's equal to the whole length of 23. Okay, and then we would set up and solve. So this is the part we're going to be good at, like terms, add 16, and then x is going to equal 13. Okay, so that's the algebra. Now all we have to do is set up the proof for it, okay? Same thing with the angle addition postulate. This smaller part plus this smaller part is going to equal the whole outside part, hij. If you are struggling with naming angles still, I would draw this diagram and just flatten out hij. So that's the big outside angle. And then I would draw it like this. Even though they're both not perpendicular, it might be a little bit easier for you to see. So again, on this one, thinking about the whole angle versus the parts, right? So this would be A, D, C, and B. And then in the diagram, it gives ADB is x plus 7. BDC is 2x plus 19. And then up in the directions, it says ADC is 59. Well, that's the whole angle. That's 59 degrees down here. Find the value of x. So this works the exact same way as segment addition. Okay, and then we would collect our like terms. Subtract 26. And that's going to be, 33. And x is 11. Okay? So those are the geo concepts that we're going to look at today. There's other things like bisect. Remember, if you're using bisect, it cuts things in half, so you could set them equal to each other. We would use definition of bisect. Okay, so let's go through. They give us the picture, and they give us this, NM plus MO equals NO. All right, that's given to us. That is also the segment addition postulate. That's really what that segment addition. NM plus MO is equal to the whole, right? But let's go ahead and write our equation. 2x plus 3x minus 9 equals 4x minus 4. And then in a reason, that's going to be the segment addition postulate. All right. And this is where it's nice to have that algebra done. But now I'm going to collect like terms. 5x minus 9 equals 4x minus 4. Combined like terms. Or that word simplify. Okay. Then we would subtract 4x. And then we get x minus 9 equals negative 4. And this was the subtraction. Property of equality. Okay. Technically, then this would be simplify. I'm just going to leave that a blank. Then we would add 9. And you get x is equal to 5. And then how do we add 9? That was the addition property. And then in these blanks, when you are doing the math, simplify would be the term. If you don't put simplify in, I am not going to complain a ton. It's just spacing out our math, right? Instead of trying to like squish everything together. So if you do subtraction and then you do the 5, like here, you did the subtraction property and then you subtracted 4x. We simplified that down. So that's what you can do to fill in those blanks. Okay? All right, so what do they give us? It gives us xy equals 2i plus 37. That's given. We need to find y, so in the end, y is going to equal something, right? So what are we going to start out with? So go ahead, pause the video, you try this out. I'm just going to flow right through it. So part plus part equals the whole. I'm going to combine my like terms. Oh, how do I know that? That's what allows me to write that equation. Segment addition postulate. All right, well, let's combine our like terms. 7y plus 27 equals 2i plus 37. We combine like terms. And now we're going to subtract 2i. That was the subtraction. Property of equality. And then we simplified. And we subtract 27. And then divide by 5. So division, property of equality, and then we simplified, and we've got y. All right, so that's the concept. That's the idea of geometric proofs. Is now we're going to have to use that definition, that postulate, that theorem to get us rolling. All right, and then we'll do one more. We got a bunch. Oh no, we got, and I'll fill in the last one. I'll do one more with the angle addition, and then we'll jump to that last one. Okay, so what do they give us? They give us the figure, right? And so in the statement, what we would do is we would just draw that picture in right there and say that's given. All right, we don't have enough space for that, so we're just saying the picture, that information is given. All right, based off of that, what's the equation that I can write? Part plus part equals the whole. Okay, what allowed us to do that? That's the angle addition postulate. All right, and then from here it's the algebra, right? So we did the geometric proof, bam, right there. So we would add the 3x and the 6 together, 9x. 5 minus 16 is negative 11. Yikes. 8x. And then all we did was combine our like terms. And then we'll subtract the 9x. Here, I'm just going to finish my proof, and then I'll write everything. Or I'll finish my algebra, and then I'll write everything. And so we get negative 11 equals negative 1x. And then we're going to divide by negative 1. And get x is equal to 11. All right, so let's fill in. This was the subtraction property. We simplified. Then we division property. We divided by negative 1. And then we simplified. All right, so here's the little kicker again, a little disclaimer, right? So it's just asking us to find out x. What if it said in the top, find the measure of ABC? All right. So we know ABC is equal to 8x. That was given. So then in the end, this was a test, right? You would take and substitute that x value back in, right? So then if it asked us to find out a specific angle measure, then we would do, since we already wrote that given up there, you can write it again. Measure of ABX is equal to 8x. Or since we already said it was given, then we would just substitute in, what do we get? X is equal to, it's right above it, 11, and that would be the substitution property. And then measure of ABC equals 88 degrees, and that would be simplifying or just doing the math, okay? So this extra step down here, these extra 2 steps, would be taking it to that next level. If they're asking you then to go ahead and find out a measure, then we would substitute in substitution property. All right, let's jump to that last one. Okay, simple. This is a simple one. Okay, but it's got one of those 3 new ones that we were talking about. So what do we have here? They give us just a line segment, right? XY is the line segment. So what do they give us? Given XY line segment. What are we trying to prove? That's going down. That should be the last one. We have to prove xy is equal to itself, or sorry, is congruent to itself. So if we can prove that it's equal, then we can prove that it's congruent. So what we'll do is we just got to fill in one blank right here, right? And based off of what's there, we have xy is equal to xy. What property was that? That's the reflection one, right? Reflexive property of equality, all right? POE. Now we can use the property of equality because it's an equal sign versus the property of congruent because of the congruent symbol, right? And then at the end, all right, how do I know xy is congruent to xy? Then that's just the definition of being congruent. If they're equal, they are congruent. So that's our beginning journey into geometric proofs. Awesome job, guys. Have yourself